on your check-in, it says, two cars exert force with their engine. Technically it's torque because it's force in a circle.
Steve, we're aware the internet is extremely slow right now. Please be patient. We're working for a solution. Thank you.
Everyone at home, I hope your internet is working. They just can't, if you didn't hear it, they said the internet is extremely slow here right now, so there may be some kind of problem. Well, two cars exert force with their engine. Technically it's torque because they're doing it in a circle with the spinning and the wheels and the drive shaft and whatever they've got. They have equal mass to each other, the cars. They go exactly the same distance and they're on a level surface. But one car exerts more force, torque, than the other car. Which car has the biggest change in kinetic energy? What's kinetic energy again? It's a long time ago. Megan, you remember? Yeah.
I don't know.
Yeah, no, it's hard. Kinetic energy is energy of movement. So it's basically asking which one is going to be going faster. And it says one car exerts more force than the other car, so the one that would be going faster is the one that did more force. And it's not really a math question, I just included these formulas so you can see kinetic energy has to do with mass and velocity. It says they have equal mass, and so the only thing that could be different is velocity, and if one car does more force, then it'll have more velocity. Okay. Now, if you're still working on your lab from yesterday, I said we'd have time today for y'all in class yesterday to finish. Where are we? Here we go. All right. So I'm going to make up some numbers, and I'm going to try to make them all made up where it's not numbers that you would have gotten. So let's see. I don't know. I don't think I can make anything up. Let's see. So after the collision, let's say that my empty cart, when I hit it on fast, let's say that it went fast. And I wrote fast 3. Remember that 3 is just the number that we're going to use to plug in for fast once we do calculations. It didn't actually go 3 meters per second. We just don't want to actually measure its speed. We just want to do momentum in this lab. So we just say, okay, it went fast. And when we hit it going slow, that's the empty cart. Let's say that it went slow. And these results might be common, so you might have gotten the same thing, but if you got something different, make sure you use your numbers. All right, the weighted cart. So you push this cart into the cart with the thing on it, the little mass, or whichever you got to use at home. And I know this was probably difficult for y'all to find materials. Our next lab, you're gonna have to push them and they're gonna have to stick together. So you may have to find a loop of tape or something to put on one. I understand that might be difficult. Please let me know if you have any difficulty. Send me an email or something. So all right. When you hit the weighted cart with the propelled cart going fast, let's say that it went medium. And I said that you didn't have to say medium. So if you didn't, if you just wanted to say 1 or 3 for slow or fast, then that's fine. But I'm going to say that it went medium. And then when you hit it on slow, let's say the weighted cart went slow. So let's also assume that after the collision, the propelled cart stopped every time. This is the cart that you pushed, right? So let's assume that it stopped every time. And I know y'all's carts might not have done that, but for mine, let's assume that that's what happened so I can show you how to do the math here. So, okay, one easy thing before the collision is these right here. See, it says momentum before the collision, momentum after the collision. So before the collision, one of them was stopped. The propelled car was the one you were pushing, so it's not that one. This was stopped. And since momentum is mass times velocity, that's what's going in each of these boxes. And if the velocity is 0, then that would be 0. So velocity 0 here, velocity 0 here, 0 here. I'll just circle this formula over here. So that's what we're putting in each of these boxes except for the total. Because velocity was 0 for these, that was when that one was just sitting there before it got hit, before the collision. That's why that's 0. And since we're assuming that the propelled cart stops after the collision, all these are going to be 0. So it's a little easier than it looks, what with all these boxes. For these, there will be a momentum. This is the propelled cart, and it even tells you when you push the propelled cart fast, what's the momentum. So if our formula is P equals M times V, the mass of the propelled cart, now people at home, you would have estimated your mass of the propelled cart, but we know the mass of our carts, they were 0.25. And we pushed it fast, and we're saying that fast is 3, just to get a number. So that's 0.25 times 3, which is equal to, here, let me write that real small. 0.25 times 3 is equal to 0.75. And then for slow, 0.25 times 1 would be 0.25. And now these total rows, you say, okay, 0.75 times, or plus 0, so you've even got the little plus in the equals there to show you how to do the totals. So 0.75 plus 0 would be 0.75, and 0.25 plus 0 would be 0.25. And now over here. This is the weighted cart. This whole other table is for the empty cart, so we got to make sure to use the weighted cart numbers. So after the collision, the weighted cart went medium when we hit it on fast and slow when we hit it on 1. So this row is when we hit it on fast. So my weighted cart would be, it's 0.45 because our mass that we put in it, the objective known mass, was 0.2. And the cart itself was 0.25, so 0.25 plus 0.2 is 0.45. You have to add those up for this, for the weighted cart. So okay, when we hit it on fast, it went medium, so that one will be a 2. When we hit it on slow, it went slow, so that one will be a 1. So 0.45 times 2 is 0.9. And 0.45 times 1 is 0.45. So 0 plus 0.9 is 0.9. And 0 plus 0.45 is 0.45. And then at the end it asks you to compare your totals. You'll fill out this chart too. You'll just use the empty card over here. I'm not going to do that whole thing. But our total was 0.75 and then it was 0.9. So they were both high. And this one was 0.25. Those are 0.45. That's a little bit bigger difference there. But it's supposed to be about the same. But in physics, it's difficult to make our labs work exactly right, especially when we're not actually measuring the speed. But I thought that would be just too much, make it take too long, etc. But I hope that'll help you all finish your lab here. We will have other things to do, but the videos, the Study.com lessons, will be just for if you have time after you finish your lab. If you've already finished your lab, then you've got something to do.